Hello, let's continue our Sudoku adventure with Interchange by ChinStrap. So this continues our palindrome theme week. Hope you're enjoying it. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these clues outside the grid. These are skyscraper clues. So the way these work is imagine that you are standing on top of the clue looking in the direction of the clue. So here looking in this direction. Now imagine that every digit in the grid represents the height of a skyscraper. So let's say this was a 2. Then what we're going to do is we're going to count how many skyscrapers we see. So with the 2 and then maybe a 1 here, we would see the 2. It's right in our face. But the 2 is too tall. It'll cover up the 1. So we won't see the 1. And in general, you can think, okay, we're only going to see digits that are bigger than all of the previous digits. So this will always be seen, whatever it is. Maybe it's going to be a 5. So we'll see that. And then now we could have, say, 3 here. And the 3 is not seen because it is not bigger than all the previous digits. The 5 hides it. Then we can have the 6. You're always going to see the 6 because it's taller than everything else. And then the 4 goes here and it's not seen. So if we count the number of greens here, the number of skyscrapers we see 1, 2, 3. And that matches our clue. So this is one way we could fill this row, one of many ways. All right, we also have palindromes in the grid. That's our theme this week. The way palindromes work is they read the same forwards and backwards. So if this was 2, 4, this would be 4, 2. So it would read 2, 4, 4, 2, and 2, 4, 4, 2. So another way to think about that is that digits that are equidistant from the center are the same digit. So these two are the same and these two are the same in order for that property to hold. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right. So a 2 skyscraper is limiting in an interesting way because we're always going to see the digit that's in our face, and we're always going to see the 6. But that's it. That's it, right? So we can't put a 6 here. But whatever we put here, we need all digits smaller than it until we hit the 6. So there's not a whole lot of good ways to sort of mark that. 4, on the other hand, is a little bit different. For 4, we need to see a lot of digits, 4 out of the 6. So we can only be hiding 2 digits. And so this has to be fairly small, and then it can get larger as we move out. So how small can it be? Well, obviously 1 is fine. It's not hiding anything. The 2 will hide the 1 wherever it goes. So that's hiding 1 building. The 3 will hide the 2 and the 1. And that's our max, right? We can only hide 2 digits. So if we try to put a 4 here, the 1, 2, and 3, wherever they go, will all be hidden. So we'll see a maximum of 3, which is no good. So this can be 1, 2, or 3. And then that translates over to here as 1, 2, or 3. And then this can be 1 larger. Because this is not hidden. So it can be a 4, because if it was a 4, we would not be hiding this 1, 2, 3, just the other 2. So maybe like this, right? We'd see the 3 and the 4, and we'd hide the 1, 2, and we can still complete 4. So, but it can also be a 1. There's no reason it couldn't be a 1. So this is 1, 2, 3, 4, and it's cloned here. Now this is 1 through 5 for the 4, which you're just following the same pattern, which means the 6 ends up somewhere over here. And then the 6 is somewhere up here. Now let's look at this 2 a little bit more closely because we just cloned something into the 2. So we need to be really careful because we can only see this guy and the 6, but notice how these 2 are not the 6. So these 2 have to be hidden by this guy. The only way that's going to happen is if this is a 3, which makes a 3 there, and then these are from a 1, 2 pair. So they're both not seen. And then we have to put the 6 here. Otherwise we'd see too many. So that means this is not a 6 because this isn't. This is actually a 4, 5, meaning that's a 4, 5. So now that this is a 3, it is hiding the 1 and 2. And then the 4, 5, and 6 need to be in order. So that means that because this is a 4 or 5, the 6 can't go here, or it would hide the 4, 5. We're already hiding the 1, 2. We can't hide anything else. Wherever the 1, 2 are, we're already hiding them. The 6 would hide this 4, 5 in addition to that. So the 6 ends up over here. And then now If this was a 5, it would hide the 4, which we're not allowed to do. So this is our 5, putting a 5 here, that's 4. And then this is from 1, 2, 4, right? The 4 could go in either of these. It'll still be seen, and the 1, 2 will still get hidden. So that row is resolved, kind of. We've made good progress on that row, I guess is one way to put it. Do we want to talk about this 3 maybe? So 3, this can be 1, 2, 3, 4, but that's just the entire box is 1, 2, 3, 4. But we can't keep getting larger here. So, okay. The 6 is here, though. We're hiding these 2 naturally. So we're always going to see this guy, and then we're going to see one of these 2, but not both. So we can't strictly increase, I guess is one conclusion there. So this can't be a 4, because if it was a 4, so let's think about this. If this was a 4, it would hide both of these, and then these would also be hidden. We'd only see 2. So this is not a 4. If this was a 3, that's fine, because we can put a 4 in here along with something hidden by the 3, and then this hides the other 2. So this isn't a 4. That's all we learned. What about this 3? I mean, it can't be a 5, because then we'd only see 2. It's not a 4. So, it's 4 or 5 are gone. So I guess this is just... Oh, it can't be 3, 4, or 5, and it's not a 6, because this totally breaks the skyscraper. So this is 1, 2 only. But I don't know what that does for me. If it's a 1, we automatically see this one. Okay, then that's no good. Well, no, it could be. It would be forced to be a 5. So if this is a 1, what I'm saying is if this is a 1, this has to hide the 4, because we're also going to see the 6. This can't be a 6, ever. So I guess one conclusion is 6 is over here. This is from 1, 2, 3, because it can't be 4 or 5. And it's definitely not a 6, or we'd only see these 2. So is that the only conclusion I can get from that? What about this 2? This is interesting. So this has to be the 6, because we're always going to see this 5 if the 6 is back here. So that means this is our 6, and this is whatever it wants to be. That places the 6 here. So we see the 4 and the 6 and this guy. So we're not allowed to see this guy. So this, I mean, maybe I could have figured that out earlier. So this has to be the 2 in order to hide the 1. It's the only way that's going to work, making this the 3, 5. We know the order. That's 3, that's 5. So we see the 2, 4, and 6. Okay. These aren't 3s. This is 1, 2, 4. And this is 3, 6. The 3 tells us the order, 6 and 3. This is not a 1. Oh, in order for these to match, they have to both be 2s. That's 1 and 4. Clear out all these 4s. All right. Are there any? I don't think there's any skies. Oh, this 3 I still have to resolve. So maybe that does something. This is a 4 or 5 pair. What does this box need? It needs a 1 over here. It needs a 4 anywhere. It needs a 5 anywhere, and it needs a 6 one of these 2. Okay, 6 can only go here. So the 3 is in one of these 2, and the 2 is down here somewhere. Do I need to think about this 3 anymore? So we're hiding the 4, 5. So this can't be the 3, because if it was the 3, we would see the 3, we'd hide the 1, 2, and we'd hide the 4, 5. We'd only see the 3 and the 6. So this is not a 3, putting the 3 here. That places this 3. This is now 1, 2, 4. This is 1, 2, 5, not a 2. And this is 1, 2, 4 as well. Now this doesn't care. Now, okay, let's keep looking at this. We are going to see this 3 and this 6. So this better be a 2, so we don't see the 1 and the 2. So that's 2 and 1. We can clear all this out. Oh, and the 1 translates here. That's helpful. That's 4 and 2. That's our 5, 4, and 1. That's 5 and 4. That's 5, 2, 4, 1. And we're done. Correct solution. Nice. All right, nice puzzle, ChinStrap. I can see that this was kind of the initial idea of having a 4 and a 2 kind of fight over how what these first 2 digits are going to be, which is pretty neat idea. And then the follow through is quite nice as well. Well, let me know how you did, and if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.